Hello everyone, welcome to my presentation. This is Yuvaram and in this video I'm going to walk you through the projects I have done in the field of robotics till now. These are the list of projects which I have done through the course of Robotics Nano Degree and Self-Driving Car course offered by Udacity. They cover a lot of fields from image processing to deep learning to machine learning to sensor fusion. All those things are covered in these listed projects. In this project, I'm going to control a rover in an unknown terrain through my code using image processing techniques. This rover has a camera mounted on top of it from which it can capture its environment. Based on the environment, I'm going to decide where to drive the bot and where not to. For example, mountains cannot be driven. They are marked in the red color, and blue color represent the drivable area, which is of course the sand, which is in white color. This also simultaneously map the environment which is shown in the right hand side of the video. The map is automatically generated through the rotary encoders mounted on top of the wheels of the rover, and the pixels classified as drivable area and non-drivable area. The old map, the world map has red color markings which defines the mountain, and the blue color markings on top of the green color map which defines the explored areas, that is the areas which are already covered by our rover. Our program makes uh, decisions when to stop and when to turn. As you can see, when it approaches the mountain which is closed to it with no way to go through it, our rover decides it's a good time to turn back on the path. This process of exploration will continue as long as our rover finds the optimal position, which I have hard coded inside the program uh, called as the base station. This can be used in rovers which are allowed or asked to explore an environment. In this project, my code is going to decide when to change lane. When we are in a highway uh, and we have a car slowing down in front of us, if we see an opportunity in right or left lane, then we will change to the fastest lane. So this code is going to mimic the implementation of LiDAR and radar and the sensor fusion technique to uh, decide when to change lane and when not to change. Obviously, when a car is in front of us, we have to decide if should we change lane, or is it safe to change lane, or will that lane change cause us any trouble. As you can see, suddenly a blue car pulled in front of us and our car decides to change lane. This is another scenario where our car detects a slow yellow car in front of us and changes lane. Okay, what if we are in a crowded environment surrounded by other cars and we don't see a safe lane change? Our program waits till the cars are passed and then makes a lane change. So this is much safer to get with. Before getting into the project explanation, let me tell you about the semantic segmentation concept. It is a concept in deep neural networks where an image is classified pixel wise. That is, if I give you a picture of a crowded environment, that we know how to classify between a human and other obstacle or an object or a shop or a handbag, laptop, everything. So semantic segmentation is a concept where uh, automated where our computer can detect difference between objects. I'm running this experiment on my laptop, which is a bit slow for these kind of tests. These kind of tests obviously require a server or a high-end system to run these kind of process. This may be slow and lag, and this is due to my laptop's inefficiency. So I'm going to start my simulator, and the black screen is the screen where we will see the classifications going on done by my code. My code basically a neural network. So I just started it. So our quad is sending pictures taken from its camera to this classifier, this other small screen, and the small classifier is detecting which is building, which is which are our peoples, and which are is our hero. So there are three classes: building, which is shown in red color, and peoples. Peoples are shown in green, and the blue here is our hero. So we have designed a program to find our hero in between all the other peoples and classify difference and find difference between our hero and other peoples. These kind of applications can be used in designing robots to follow a target. As you can see, my program does suffers from misclassification. It just now classified my hero with green colors too, but these things could be avoided if we use a high-end system other than my laptop. Simultaneously, it is able to classify between other humans as green and my trained hero as blue. So all these things are done using neural networks. You can see a lag between the simulator, which is running a bit faster than the processed one. This thing is due to my hardware incapability of my laptop. I'm going to send in this raw video into my algorithm to check whether it's able to find the lane in which we are driving. Wow, it detects. See, the green color markings are the lane which in which we are driving, and it's able to determine the radius of curvature using a polynomial curve fitting, which is shown in the top right hand side. It is able to detect the center of our car and the alignment offset between the our center and the road center. These informations are highly valuable when you want to create a self-driving car or a self-driving robot which needs to go inside a confined space. Wow, this is my favorite project. This is called as behavior cloning. So it just seems like a car is driving on the road by its own. Basically, nobody is controlling. So the process behind this is what I did is this program can mimic its users' driving behavior. So what I did is I drove this car uh, for 2 laps on this road. So while driving, I took pictures and recorded my steering commands action. So when I turned right, when I turned left, when I was going straight, and the degree of my turning. Based on those things, I then fed those images and my steering commands to my deep neural network program, who can learn uh, how to drive based on my behavior. This is called as behavior cloning. It has no pre-coded PID controller. It has no uh, model predictive controller inbuilt. It just purely runs based on my behavior, and uh, it can learn from that when to turn right, when to turn left, and what to do if something unexpected is happening. If you are wondering what this shabby piece of video feed is, this is the video which is going inside my algorithm. My algorithm learns from this video, that is a camera mounted on top of my car, and uses my steering commands to predict when to turn. Now you can see the difficulty in executing this program. So it's not an easy task for a computer to learn from this kind of a shabby picture to drive on a road without harming others, just based on its users input, just based on its users previous input, to be correct. Nobody is controlling it while it is in the autonomous mode. The code is controlling it in the autonomous mode. This is a hot topic in self-driving car. How can a computer classify between a road object and a vehicle? This is how it's done. My algorithm can detect vehicle uh, based on its image, nothing else. No need for distance or any other sensory input. It just takes raw image and classifies whether that is a car closer to us or further forest to us. So right now it's able to detect two cars, a black one and a white one, in our same lane. So these things are crucial for guiding a vehicle in a highway. With this, I come to the conclusion of my project demonstration. I've done a lot of projects related to robotics, and I'm a robotics enthusiast and a hobbyist. I like to work on real-time projects where I can utilize these knowledge which I have to see a real life project. Thank you.